Hello and welcome to this session where we revise the reactions from alcohol and phenol. Now these are some of the basic reactions. Of course you have a liberty to pause the video, solve it mentally, and then after doing that you can verify the answers. I am solving it one by one. Question number 1. This is phenol in presence of zinc dust. It gives us benzene, a typical way to convert a phenol into benzene. Second is a name reaction. This is cumene hydroperoxide reaction. Isopropyl benzene is called cumene. Isopropyl benzene is called cumene, and the reaction is cumene hydroperoxide. What happens over here is a first creation of a peroxide. So we have C. This is OOH, and CH3 attaches over here, which rearranges to give us two commercially important compound. One is phenol and second is acetone, CH3COCH3. Next, this reaction is an example of a coupling reaction. Now coupling reactions are uh, used in preparation of the azo dye. So when we say azo dye, it means it has a N double bond N linkage. So reaction happens from this side in the para position, and we get a dye whose structure would be like this. We have benzene OH, then N double bond N and a benzene. This is the structure of azo dye. Next is the Elb's persulfate reaction. So it creates additional OH at ortho and para position. Ortho and para position. Right. This is catechol. This isomer is called catechol, and this is quinol. Next reaction. This is an example of a ipso effect where the bromine water will give us excess of Br plus. So what effectively happens is that OH is activating group, a plus R group. So we have bromine at the ortho position, but SO3H is also replaced by bromine. This is the strange thing happening, and this is called the ipso effect. Now which compounds can show? Phenol or aniline. It can be phenol or NH2, or here it can be SO3H or it can be a carboxylic acid, but they should be present at the ortho on the para positions. Only in that case they are replaced. Next is the periodic acid oxidation. Now when we talk about say periodic acid oxidation, it breaks at every adjacent OH carbon-carbon bond containing OH, and every fraction is oxidized to the next higher level. So the first fraction will be oxidized to next higher level, which is the aldehyde, so we get a aldehyde. Second, note that it is oxidized on left also and right, so it will have two stages of oxidation. So it will convert from alcohol to aldehyde and then to acid. So one carbon acid is formic acid, and the last one, it is oxidized only at one end, so it will be converting into the aldehyde. So these are the fractions which are formed. Next, this method is used to convert primary amines into alcohol, right? Of course the reaction proceed via formation of the diazonium cations, which is in fact replaced by OH and giving us two carbon. This is ethanol over here, so we get ethanol formation. Next is the acetal, and the this is basically because you're starting with the aldehyde, so it will be acetal, hemiacetal acetal formation. Alcohol is acting like a nucleophile because it contains electrons, so it is going to attack over here. And if only one molecule adds, which you can see as a nucleophilic addition, then it is called hemiacetal. And then if in presence of excess CH3OH, if this OH is also replaced, then it will be called as the acetal. Hope you got this. Now if you see question number 9, it is not a different thing, it is the same as the previous one. Here we don't require two molecules because only one molecule of glycol has two OH bonds, two OH groups. And so what happens? It will form the ketals. Why ketal? Because we're starting with a ketone. So this is the formation. Actually, this is same as question number 8. This is the cyclic ketal which is formed, and the cyclic ketal which is formed is actually a way to prevent C double bond O. So if you have C double bond O and if you don't want the reaction to happen at this end, you can preserve it using glycol. This molecule is glycol. Next is a very simple reaction. This is alcohol plus acid, so it's an esterification reaction, forming as giving us ester, which is CH3COO CH3. So these are the important reactions of alcohol and phenol. Hope you like it. Thanks for watching this video. Best of luck.